Yeah, good day, my students. In this video, I want to talk about SP hybridization. We then look at bonds in a time or a time. When you look at this carbon, this electronic configuration of carbon in its ground state, without excitation, without hybridization. When it is hybridized, in the excited state, it will look like this. This is 1s2. This is 2sp1, 2sp1. And this is 2p1, 2p1. In case you are confused, you need to look at my previous videos where I discussed sp3 hybridization and the sp2 hybridization. You also need to find out the meaning of sigma bond and the meaning of pi bond in my previous videos. But in this video, I want to look at sp hybridization, and we are going to talk about bonds in ethine. Ethine has this structure. This is the structure of ethine, structural formula. So this is the structural formula of ethine. Now, what is going on here is very simple, and you must make it simple. If you look at this carbon, the electronic configuration of this carbon, in order for it to have the different types of bonding it requires in this structure. This is the electronic configuration of this carbon. This is also the electronic configuration of this carbon. All right. The question now is this: how does carbon use this electronic configuration in bonding? Okay. We know that this bond is a covalent bond. This hydrogen has only s orbital. So this carbon is using 2sp1 here to bond with s1. So that means this bond, this orbital is used in order to bond with hydrogen. So the bond that we have here is 2sp1 s1. And this bond is called sigma bond. In my previous video again, I've explained the meaning of sigma bond. All right, that one is done. The same thing applicable here. I don't need to waste my time here. So we have 2sp1 and we have s1. And the bond here is also sigma bond. So that means we have taken care of this and we have also taken care of this. All right. Now, the next step that we need to take is, what about this? What about this? And what about this? This carbon has these three orbitals left for bonding. This carbon has these three orbitals left for bonding. As a result of that, the next thing is that what happens here, what happens here, and what happens here. These 2p here and these 2p here are used here. So we have 2sp, 2sp1, 2sp1 here. This bond is also sigma bond. You can check my previous video. We are left with these two. The remaining orbitals we have here are this. The remaining orbitals we have here are this. For this one, we have 2p, 1 here, and we have 2p, 1 here. And for this one also, we have 2p, 1 here, 2p, 1 here. But what is the name of the orbital here? The orbital here is known as pi bond. Why? Pi bond is always formed by p and p orbitals, but those p and p orbitals must be arranged vertically to each other. They must be arranged vertically to each other. I explained that in my previous video. Look at this. Look at this. So this is a pi bond. Check my previous video. This is a pi bond. So this is a p orbital. This is also a p orbital. They are arranged such that they are vertically placed together. All right. The same thing applicable here. We have pi bond here. All right. So this is the bonding system in a time. So if you are asked any question here, how many sigma bond do we have? Of course, we have one here, one here, one here. How many pi bonds do we have? We have pi bond here, we also have pi bond here, and that is all. In my next video, I want to show us the bond angle of all these bonds. The bond angles of all this. What bond do we have for sp3? What bond do we have for sp2? What bond do we have for sp? And so on. So thank you so much for watching this video. This video is from my prof tutors. Thank you.